Hi everyone. In this video we're going to work through the problems in the point slope classwork worksheet. All the equations that we write for this particular worksheet will be written in the form y minus y1 is equal to m times x minus x1. So for this first problem, problem number 1, we're given a slope of 3 over 2, and that's our m value, and we're given a point where 3 is our x1 value and minus 1 is our y1 value. So we can rewrite the general form of the equation. And we're just going to substitute values into this equation. Y minus 1 is equal to 3/2 x minus 3, and we'll get rid of this double negative that's in here, and this becomes y plus 1 is equal to 3/2 x minus 3. Our second problem asks us to write the point slope form of the equation of the line at minus 4, 4. So we're given, right from the problem here, we have our x1 is equal to minus 4, and our y1 is equal to 4. We have to find the slope. We're given a graph here, so we're going to pick 2 points on this graph, and I am going to pick the first point, P1 will be at minus 2, 0. And I'll pick a second point down here, and P2 will be at 0, minus 4. I'm going to use my slope equation. And I'm just going to plug in values here. So y2 is minus 4. y1 is 0, and that is over x2 is 0 minus 2. This is important. If you wrap your x1 in parentheses, you won't, you'll be less likely to make a mistake with the negative signs. So this reduces to minus 4 over 2 is equal to minus 2. So now we have our m value, and we have our x1 and our y1. We can rewrite our general equation. And now we're just going to substitute values. So y minus 4 is equal to minus 2. X minus, and once again, I'm going to put parentheses in a different color here so that this is a little more obvious. Minus 4. And when we rewrite this portion in here, we're going to get y minus 4 is equal to minus 2 times x plus 4. Number 3, they're asking us to write the point slope form of the equation of the line given the slope and the y-intercept. So we have m, that's being given to us. what we need to interpret about the y-intercept is that we know that it occurs at x equals 0 and this is the actual, the y coordinate is the actual b value that's given. The y-intercept is always 0, b. So this is a point. And we have our slope, we have a point, an x value that we can use, an x1, and a y1 value that we can use, so we will rewrite our general equation. We're going to substitute those values in, and we get y minus 4 is equal to minus 1 times x minus 0. And when we simplify this out, we get y plus 4 is equal to minus 1x, which is also y plus 4 is equal to minus x. Number 4 asks us to write the point-slope form of the equation of the line through the given points. So this is very similar to the ones that we did with slope-intercept form. We're going to label our 2 points. And we know that this is going to be x1, and this is our y1. And this becomes x2, and this is y2. So the first thing we're going to do here is calculate our slope. And we know that m is equal to y2 minus y1 divided by x2 minus x1. We're going to plug those values in. y2 is minus 3. We're going to subtract a minus 5 from that, from y1. x2 is minus 2. Minus x1 is 2. And this turns into 2 divided by minus 4 is equal to minus 1/2. So we have our slope, and each of these points can be used. Either one can be used to finish off the equation. In fact, we'll go with both. Let's try the point P1 first. So if we rewrite our general equation, and we're just going to substitute values in there. So for P1, we have y minus 5 is equal to minus 1/2 is our slope times x minus 2. And I'm just going to rewrite this to get rid of the double negative. Y plus 5 is equal to minus 1/2 x minus 2. And let's give a little squiggly line over here, and just to separate things out. And we'll try this with P2. Y minus y1 is equal to m times x minus x1. And we're going to substitute some values in there. So y minus 3 is equal to minus 1/2 times x minus 2. And we'll rewrite that to get rid of the double negatives. Y plus 3 is equal to minus 1/2 times x plus 2. And let's just circle those to make this clear. we have two different representations of the same line, and this is very similar to our last video when we showed that you can have multiple representations for the same line, for the same solution set, and it just depends upon the point that you select as your x1, y1 value. Number 5, they're asking us to write the slope-intercept form of the equation of each line. They're giving us a kind of a different expression here. This is that we don't see any x value in this, but it doesn't change anything. It just means that we have zero slope. And when this is going to be, if we recognize this as point slope version, let's write this down. Y1 is equal to m times x minus x1. Obviously, minus 2 is going to be our y1 value here. And everything on the right side of this is 0. We can actually just solve this in the same way we solved our other equations. If we're looking to write the slope-intercept form, we're looking to get y by itself. So we can add 2 to both sides, and we get y is equal to 2. There's no graph for this here, but it means that x doesn't affect anything. And if we just draw a quick little graph here at 2, it means that, let's put that up a little bit. It means that we would actually draw the graph through the point 2. For any value of x, y is equal to 2. For problem number 6, they're asking us to sketch the graph of each line. We can identify one of the points from the formula itself. In fact, let's take a look at that. We're given y minus 6 is equal to 3/4 x minus 4, but we know that our point slope form is y minus y1 is equal to m times x minus x1. Let's go to this. So our y1 value here is 6, and our x1 value is actually going to be 4. So what we can do here is we can say that some point P1 is going to be equal to 4, 6, and in order to graph the line, we have a couple of different alternatives that we can use here, but we're going to place that point on here first, and this is going to be 4, and 6, so it looks like this comes up to be right there, and this is some P1. We have a couple of different ways that we can figure out what P2 is. Let's use the idea of rise over run. We know that m is equal to 3/4, and our rise is 3, and our run is 4. If we think about what's going on here, we're not going to have much space. If we try to go over 4 and up 3, we're going to be over here someplace. So we can alternatively look at this as minus 3 over minus 4. And we can consider minus 3 to be our rise and minus 4 to be our run. Our point is 4, 6. We're going to add our run value to the x, and we're going to add our rise value to the y. And we're going to come up with P2 is equal to 0, 3. We're going to place that on our graph, 0 and 3. And this is some P2. Let's get rid of this stray point over here. And now we're just going to draw a straight line through those 2 points. And we don't forget the arrows because this goes on and on forever. And that's it. Those should serve as a good example. Try the point slope exit ticket problems. And if you want to email those to me, I will give you some feedback on your work. Thanks for watching.